So let's now look at pattern recognition in shale. Now that we have all this data, let's examine them to see if there are. I hear a lot of people saying that shales are statistical plays. I'm not sure I quite understand what that means, and I'm not sure, for whatever is it that I understand from it, I agree with it. Simply because traditional statistics really fails to give us anything from these data. You can use these technologies that are available, and our industry has recently been using them. I call them glorified Excel programs. They're essentially data analysis tool that they just provide you with different views of the data. They're good, don't get me wrong. I just don't think they provide what's required of data-driven analytics. They're just they can provide some statistical analysis, and I'm going to show you some of that when applied to Shale, and demonstrate that there is not much that you can get from them. You can perform 2 and 3D dimensional plots. You can do normalized plot. You can do frequency distribution, and what you get really is not much different from what I'm showing you here. So in this few slides, what I'm going to show you is in x-axis, we have what's shown up here. For example, here the x-axis is northern endpoint, which essentially is latitude. And on the y-axis, we have what we call production indicators. Here it is 180 days cum gas production in MCF. So when you plot the production indicator versus northern endpoint or latitude, you see this blob of data. And if you do that for inclination, again, x-axis is inclination, y-axis is production index, 180-day cum. And again, you see this blob of data. There is no pattern that can be deduced from that. If you go to reservoir characteristics, for example, this is water saturation versus productivity index or production indicator. And this one is porosity versus production index. This one is stimulated lateral length, which is supposed to provide a clear trend. And as you see, you have this blob that for the same, that's for the same value of stimulated lateral length, you have low productivity and very high productivity wells. The next one will be average treatment pressure. Remember this, because I'm going to come back to this. Look how, what a blob. It seems to be no pattern whatsoever here in how you, with what pressures, average pressure do you frack your well. It seems it has no correspondence to how productive the well ends up being. And I will show you that although the raw data shows you that, it's not really true. You can take this data and take a lot from it. So let us classify, but when you show this to a lot of production reservoir engineers, they say, well, we don't do this only. We do log-log, we do semi-log, we do in special plots, we do normalize it per foot of thickness, per foot of lateral length, and then we put them in buckets. And, well, regardless what you want to do, however you cut it, you're not going to see any, at least in these Marcellus shale ones. I'm sure the same is true for, I've seen many of them in Eagle Ford, Bakken, and Haynesville. For example, here, if you plot azimuth versus inclination and put them in different buckets of cumulative gas production, 30 days, again, you see no pattern here. This is number of clusters per stage that is plotted versus perforated lateral length in foot. No patterns there. Average treatment pressure that I mentioned versus total clean volume. Look that there is no trend whatsoever. And here, what we have done, we plotted 180 days cum gas, which has been normalized on a per foot of thickness, and plotted versus porosity in x-axis, and then we put it in buckets based on the BTU of, this is rich gas, part of the Marcellus that has condensate. You have dry gas all the way to rich gas. Excuse me. And again, no matter how you slice it and dice it, you do not see any pattern. And here is normalized for the thickness versus water saturation. Now it is 100 cume gas normalized per foot of lateral length versus porosity for the same BTU, different BTU areas, and total injected proppant. People always, you've heard, say the more proppant you inject, the better it gets, right? Well, it doesn't seem to show that from the actual data. So these slides demonstrate that there is not even suggestion of a correlation between any of the well reservoir completion and stimulation characteristics with well productivity. So this fact points to the complexity of these systems. We always knew that these are very, very complex systems. So when conventional statistical techniques fail to demonstrate patterns, excuse me, and trends in data, does it mean that such patterns or trends do not exist? Well, not necessarily. And I show you how in terms of when you use advanced data-driven analytics. To determine if there are any hidden patterns that can be discovered from this data, what we have done is used this to perform some modeling and then interrogate the model in order to find out the contribution of these parameters. So, for example, I'm going to show you a new way of classifying the wells. Very, very simple idea. Here we use fuzzy set theory or fuzzy logic in order to identify the quality of wells. So what you see here in the x-axis, what we have is, the 180 days cume gas, what we call the productivity index or production indicator. And so from low value to high value. And in the low value, when the 180-day cume, when this productivity production indicator is low, obviously your well is poor. So in y-axis, what you have is the degree of membership of well in the class that we're talking about. So at this low value right here, a well is poor because it has a membership of 1 or complete membership in poor well. So that's a poor well. As you move to, for example, here, then you will see that the well is partially average because it hits this line, and then it's partially poor because it hits this line. I show you, for example, in this particular example, we see that this particular well that's producing at this value right here, it is an average well because the average well has the highest membership right here. Now, if I go to the next one, you will see this well that has this particular value of productivity index or production indicator. It has a membership of 0.25 in the average wells, and it has the membership of 0.75 in good wells. So this well is partially good and partially average, and the same thing goes all the way. In other words, what we allow to do is we let the wells to have partial membership. What we're saying is there is no magic MCF of gas that makes a well poor or average. It is always a transition. There's overlapping. This is how human beings perform analysis in their mind. This is called multi-valued logic. If that simple idea, let's see what a difference does it make when you do that. So if I use this, the first thing is I'm going to check, see if what I have done makes sense.